Hello again. In this video, we're going to go over section R3, objective 3, which is about simplifying expressions with rational exponents. Okay, so I'm just going to look at this third example. So in this example, we're supposed to simplify, and we assume that all variables represent positive real numbers. Okay, so let me show you how to work these out. Okay, so these are known as rational exponents. And so what we're trying to do here is just simplify this expression with rational exponents. Okay, so the first thing you want to do here is, since this has the same base, you can add these exponents together. So I'm going to add those on top. And of course, since they have a common denominator, you can just add the tops and you'll get 6 over 7. And now, since these have the same base, when you divide here, you would subtract this bottom exponent from the top one. Remember, that's one of the properties of exponents. So as a reminder, if you have x to the m divided by x to the n, then this is equal to x raised to the m minus n. And when you multiply x to the m by x to the n, that's when you add the exponents. Okay, so we're using both of those properties here, right? We're using this property to add these exponents, and then we're using this property to subtract those exponents. Okay, and so you just 6/7 minus 1/7 would be x to the 5/7. Okay, so this is simplified. Okay. All right, part B. Let's try and simplify this one. Now, I think the first thing we want to do here is we can square this term. Now, when you square that term, you multiply it by itself. Okay, so if you multiply this by itself, you would get this. And then you can rearrange the order of this. You can put the 5s next to each other. The order in which you multiply doesn't matter. So you can multiply the 5s first and then the c's. And then the d's on the bottom. And then times this d to the 5/3 divided by 2 c to the 1/2. Okay, so then here you would just get 5 squared. Okay, and then notice here you get c raised to the 3/2 squared. And then down here you get d to the 1/2 squared, all times this. So d to the 5/3 over 2c to the 1/2. Now, you could have just skipped to this step, okay? Going back to this right here, when you square something like this, you can square each of the individual letters and numbers in here. So you can say 5 squared and then c to the 3/4 squared and then d to the 1/2 squared. So you could sort of skip directly to this step, right? By the way, this is also true if this were raised to like the 7th power. Ultimately, what will happen is each of these will be raised to the 7th power. So instead of having to write it out as this times itself, we could have just squared each of these terms individually. And I recommend you doing that in the future. I just showed you this just so you could see that you can rearrange the order of multiplication and arrive at this point. Okay, and so that's kind of a property of exponents as well. If you have something like a times b over c times d and you raise it to the nth power, you can actually raise each of these to the nth power. Okay, and so that's what we're doing here. We're raising each of these to the second power. Okay, so in the future, I would just jump from this step to this step. Okay, now we can multiply exponents here, and that goes back to this rule. If you take x to the m power and then raise it to the n power, you can multiply these exponents. And so it's x to the m times n power. Okay, so here, this is really 2 over 1. And so when I multiply these exponents together, I get 6 over 4. And by the way, 5 squared is 25. This is c raised to the 6 over 4 times d to the 5/3. And then down here, you multiply exponents again. And again, this is 2 over 1. So you get 2 over 2 when you multiply these exponents, which is just 1. So d to the first power. And then I'm going to move the 2 in front. The order doesn't matter. And then times c to the 1/2 power. Okay, so then this can be reduced. So I'm going to write that as 3/2 times d to the 5/3, 2d, c to the 1/2. Okay, so then the only thing left to do here is we can use this property here where we subtract the bottom exponent from the top one. So for this base here, they both have the same base, right? C. So it's the same as c to the 3/2 power minus 1/2. Okay, times 25. The d is to the 5/3 minus 1 on the bottom. But I'm going to write that 1, right? Normally you would write this as 1, but I want to have a common denominator, so I'm going to write this as 3 over 3, which is equal to 1. And then you can subtract these because they have a common denominator, so that's going to end up being 2/3. Okay, and then notice this is all divided by that 2. Okay, so let's see if we can't finish this off. So that's 25, and then this is going to be c to the 2 over 2, because 3 minus 1 is 2, and 2 over 2 is just 1, so that's c to the first power. And then this is going to be d to the 2/3 power, right? 5 minus 3 over 3, all divided by 2. Okay, so that's part B simplified. And then let's just do part C here. Okay, so remember when we talked about negative exponents, we talked about what it meant to be like x to the negative n power. That's the same as 1 over x to the positive n power. So the first thing I would do is write this using this property. This is 1 over 81 to the 3/4 power, the positive 3/4 power. So that's what a negative exponent does. Okay. And now remember, the bottom number here is the index of the radical, so it's the 4th root of 81, and then it's raised to the 3rd power. And that's what the top number does. Okay, so then the 4th root of 81, that means we're looking for some number that we multiply by itself 4 times and we get 81. Okay, and so the number that would work is 3. If you multiply 3 by itself 4 times, you'll get 81. And so therefore, the 4th root of 81 is 3. So this is 1 over 3 cubed. Okay, and then 1 over 3 cubed is 27, so this is 1 over 27. Okay, okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.